What a day! I'm pleased to be here with you, giving the last keynote of the day. My name is Sangyeun Cho. I'm part of the team that builds Samsung SSDs that store your precious data. I join you today at a pivotal moment for our industry, the dawn of a future that will revolutionize our society. We have a name for that future: the age of data. From AI and IoT to the metaverse and autonomous cars, so many of the applications that will change our way of life will also produce humongous data. Just how much data are we talking about? According to the IDC, 33 zettabytes of digital data was generated in 2018. How much will it be in 2025, 3 years from now? Current estimates put the total at around 175 zettabytes, and that's a tremendous amount of data by any measure. However, all that data comes with a cost. The more data we create, the more power and carbon footprint is needed for data centers and to produce more semiconductors. With that, I'd like to address the fundamental question that matters most to our industry today. Is all this sustainable? Sustainability is a global issue, one that we must address together through open collaboration. Open, together, collaboration. The moment you hear those three words, you understand just how important they are. You can find them throughout the OCP's mission and vision. Samsung shares the OCP's collaborative values, and we welcome its decision to make sustainability core to its mission. And so, with all of us gathered here today, let's examine how we can create a more sustainable future for data centers from two perspectives: products and manufacturing. Before we discuss the product side of the equation, allow me to provide a brief overview of our efforts to advance open source innovation. Samsung has been pioneering open source technologies for many years. That includes F2FS, the file system that powers all the Android smartphones, as well as multi-stream and OpenMPDK. We first joined OCP back in 2015 and became a platinum member earlier this year. 2 years ago at the OCP Summit, we made waves across the industry by unveiling an open source reference storage platform called the Poseidon Project. Today, I'm thrilled to announce that, as promised, together with our partner Inspur, we have completed our contribution of the Poseidon V1 specification to the OCP community. This follows our successful release of the Poseidon OS on GitHub. We look forward to contributing our Poseidon V2 spec in 2023. Today, our commitment to innovation is as strong as ever, especially when it comes to SSDs. Our products have been adopted by data centers and system vendors around the world. We've been developing the world's best OCP-compliant SSDs ever since NVMe SSD specifications became a focus of the OCP storage project. And they've quickly become hyperscalers' most widely adopted OCP-inspired products. To me, this not only proves the effectiveness of the OCP technologies, but also shows the true power of open source collaboration. Best of all, as these products become more widely available, they will help create a more sustainable cycle. Now, I would like to take a moment to talk about the team that makes this all possible: Samsung Memory's Global Open Source Team, or GHOST. Ghost includes more than 100 engineers from various sites who have undertaken numerous projects since 2020. Our ultimate goal is to improve the open storage and memory ecosystems. Our team is heavily involved in Linux kernel and QEMU, as well as libraries such as XNVMe and tools like FIO. Efforts like these will be vital to building a sustainable ecosystem for future data centers. Achieving that goal will require even more innovative memory technologies. Technologies like SmartSSD 2.0, Memory Semantic SSD, and memory expanders. Set to roll out in 2023, SmartSSD 2.0 is a computational storage product with a built-in data accelerator. It allows you to cut processing time by more than half, improve host CPU utilization, and reduce energy consumption by as much as 70%. This makes it an effective next-generation memory product in terms of both energy and resource efficiency. The memory semantic SSD that we are developing is based on the CXL interface. It will add efficiency to the accelerators, memory, and storage devices used with CPUs in high-performance computing systems. This will allow our product to offer up to 20 times better random read and write speeds than regular SSDs. Technologies like these enable vast improvements for data centers. And when you factor in the huge capacity gains that come with memory expanders, the future of data centers looks even more efficient. We look forward to using these technologies to enable better data center system performance and data processing. Speaking of efficiency, the data centers of the future will need to better utilize space. We can optimize space by filling storage boxes with ultra-high capacity SSDs. That's where Petabyte SSD comes in. With their high reliability and a design that can be easily scaled up to create multi-petabyte racks, Petabyte SSD can serve as disaggregated building blocks for exabyte-class storage clusters. They are designed to maximize power and density efficiency, allowing us to better utilize server system space and minimize energy use. Please feel free to explore these and other next-generation technologies in our booth. So far, we have examined how Samsung products are helping to realize the sustainable data center of the future. But what about the other side of the coin, manufacturing?
The beginning of sustainability for all. Now, our technology is aimed at the Earth, humanity, and a sustainable future for all. We developed high-performance, low-energy semiconductors with our innovative technology and received carbon footprints certified by Carbon Trust for reducing carbon emissions in all semiconductor manufacturing processes. We are constantly working towards reducing greenhouse gas emission by enhancing the efficiency of gas processing facilities and increasing the usage of renewable energy. Our efforts continue to be recognized by various global organizations by reducing not just carbon emission, but water usage and waste emission as well. All of our semiconductor facilities have received Carbon Trust Triple Standard certification. Moreover, Samsung Semiconductor's independently developed CEPI provides guidelines and initiates environmental management in the semiconductor industry, thus strengthening our position as the industry leader. Samsung Semiconductor has a strong open partnership with various partner companies to foster a healthy semiconductor ecosystem.
Ultimately, everything from silicon to data centers and even data processing can benefit from going green. Samsung continues to promote sustainability in all aspects of its operation. But more efforts are needed. Together, as an industry, we need to think beyond simply developing and releasing eco-conscious products. We must focus on ways to make the entire product journey more innovative and sustainable. But how do we do that? Where do we start? We start with manufacturing. This aspect of operation is becoming more challenging for many industries, including ours. This is because carbon emissions from manufacturing are, frankly, inevitable. To make it more sustainable, Samsung utilizes a Regenerative Catalytic System, or RCS, to effectively reduce processed gas and pollutant emissions. Samsung was the first in the industry to adopt this type of large-capacity rooftop gas treatment facility. Today, we remain the only manufacturer to utilize this technology. We have also steadily expanded our use of renewable energy over the years to the point that our global sites now run on 100% renewable energy. At the same time, we have been successful in our recycling of landfill waste. As of 2020, all our sites in Korea and China have received platinum certifications from Underwriters Laboratories for recycling 100% of landfill waste. By 2025, we plan to make all our global sites, including the one in Austin, Texas, platinum certified. We are also taking steps to address water usage. By continuously improving our production process and expanding our recycling systems, we will reduce, reuse, and recycle more water. I'm proud to say that these collective efforts have led us to become the first in the industry to receive the Carbon Trust's triple standard certification. But we are not stopping there. We are taking our sustainability mission further every year. By 2030, we will recycle 99.9% of site waste and keep water withdrawal at 2021 levels. By 2040, we will reduce the amount of air and water pollutants discharged from manufacturing to reach natural levels. And by 2050, we will officially reach net zero carbon emissions. Achieving these goals will not only strengthen our eco-conscious efforts, it will also change how we manage the entire product life cycle, from the meticulous selection of materials to production and waste disposal. This is how we will develop technology that makes technology sustainable. Thank you. Like the OCP, we believe that our industry requires more accurate and relevant sustainability assessments, just like how we did with KPMG. As you can see here on the slide, our Semiconductor Environmental Performance Index, or SEPI for short, evaluates companies' environmental efforts and achievements across 4 key categories with 32 indicators. The SEPI can serve as a clear guideline for this industry. As I wrap up this session, I am reminded once again of our word of the day here at the OCP Summit: collaboration. The path to growing our industry and realizing the promise of the data center of the future lies in working together. That is what I ask of all who are here and share the OCP's collaborative spirit. I ask you to work together to achieve our common goal of ensuring a sustainable future for data centers in a data-driven world. Let's start creating that brighter future together. Thank you.